Hello, ladies and gentlemen. Good morning. A very warm welcome to T-Chat, Cooling the Cloud, Igniting Sustainable Innovation for a Resilient Future seminar organized by HKTDC. This is Patricia Yang, and it's my pleasure to be your MC today. Today, we are very pleased to have Mr. Serge, founder and Chief Executive Officer of Immersion 4. Immersion 4 is a Swiss-based startup dedicated to combating the growing demand for data and energy consumption with its cutting-edge solutions to cool data centers when achieving zero emissions. It has been awarded Most Innovative Use of ICT by the United Nations International Telecommunication Union ITU in 2019. And now, without further ado, please join me and welcome on stage Mr. Serge Conesa. Mr. Conesa, over to you.
Thank you. Good morning, everybody. Very nice to see you. Very pleased to be in Hong Kong. That's my second time, but I wasn't never thinking that I will be on stage. So here we are. I will have a question for you before starting. Each of you are drinking champagne? Of course, I don't want to be intrusive when I'm saying that. Let's say yes, assuming. Imagine that you have a cup of champagne in your hand and you want to cool the champagne. What do? Are you going to cool the entire room, or you just cool the champagne itself? Come on, guys, don't leave me alone. Don't be shy. I know you're not drinking champagne. Let's say orange juice. So you cool the orange juice, you cool the champagne. Why do you do that? Because it's taking away less energy. So when you cool the champagne, it is immersion 4. When you cool the entire room, it's a data center. So basically, there is a big waste of energy in order to arrive to the same level, which is maintaining the electronics at the right level. So what Immersion 4 is all about is about cooling electronic with liquid. Because at the end of the day, a liquid is a thermal conductor when the air is an insulator. Well, let's go back to the energy consumption. When you look at the energy consumption, you look about, okay, what is existing today? So basically, what are we talking? Today, there is a lot of people speaking at the COP28, talking about energy, talking about reducing energy emission, talking about everything. Okay, that's fine. So in numbers, what that means? In number, what that means is today we're in a world where 89% of energy consumption worldwide is directly related to fossil energy. And only 11%, including nuclear, are only dedicated to the energy itself. So what we see today, those numbers are pretty accurate, 2021. All the sources are in the presentation if you want it later. But what you will see is basically the energy growing, okay, is quite massive. And this is at the scale of a planet. When we go down and when we look at data centers, okay, where this is the little dot on the bottom, what is energy consumption from a data center? Means nothing, really, on the scheme of things. But if you really look what this dot is all about, we are talking about if we will be using, I would say, Immersion 4 technology, saving 8.5 nuclear plants, and which can power 7.4 million households, I would say, in the world for free at this stage right now. So the big elephant in the room you have on all those graphs is what? Is what is the biggest source of energy this planet is having? It's eco-conservation. Basically, if we use energy for what matters, we can save so much energy. What is the benefit of it? The benefit is quite simple. When you want to produce energy, you build a plant. Then you have a distribution. Then you have a transportation. Then you have storage. That's a full chain. When you save energy, you don't have anything to build. And you keep the energy for what matters. So that's the point where we want to go. If you're really looking today about what nuclear energy is all about, we are going to say there is 436 nuclear plants in the world, 59 are in constructions, and 213 are on phase out. And you have other renewable energy, but still, oil and gas is one of the biggest ones. What is interesting to see in terms of energy production is we're talking about 0.01%, okay, on nuclear. Why I'm making a focus on nuclear energy is quite simple. Maybe I'm speaking too fast, I'm sorry, I'm going to slow down. Is due to the fact that today everyone speak about decarbonized energy. And it is very important to understand where do we stand, what that means. So, speaking of which, what is the household energy consumption in 2021? And we realize that depending from where we are, the average is 3 megawatts. If you go to Africa, we're on 1 megawatts, and if you go to Europe, we're on 10 megawatts per household. What is the electricity production? Before that, we spoke about energy as an overall. Now we are speaking about electricity. And what we see today is energy consumptions go to 28 terawatts. 28 terawatts with the nuclear energy in terms of energy produced, we're talking about 9.2% of the world energy production for electricity. Again, the big elephant in the room, if you save that energy, how much can we save for just using energy for what matter? Well, if we expand, we look at, I will say, what could be the real source in terms of decarbonized, I will say, energy that we can use today in this world. I wish nuclear will be one of them. Okay, it is one of them, but it's not going to be the one. Okay, we need to really have a complete rethinking on the way, okay, we are producing energy. It's easy to say. There's a lot of people on the COP28 thinking about this. The problem is we are 8 billion in this planet, and we are growing at 1 billion every 13.7 years. Do the math. So that's a gigantic problem. So still, again, saving energy is the best way we can do it. There's a principle that we all use and we don't know. There is a rule called exergy. What is exergy? It's basically when you build something, you isolate it. And when it is isolated, then you power it because you're sure that at that time, the energy you're going to spend either to cool, to heat, or to light, that construction is going to be minimum, is going to be optimized. This has been done from the beginning of time, before even, I would say, energy as we know it was existing. Arabs were doing that when they were doing the wind tower. At the bottom, it was a zeolite. With the heat, they were creating cold, and this is why they can stay in the middle of the desert. So let's look, and let's go back to the fundamentals. Well, that is the trend. What the trend is telling us. The trend is telling us that we need to do something. And this is not building a massive in renewable energy worldwide who's going to be an answer. It needs to be bundled with an eco-conservation base. We need to put together in motion the exergy principle. Let's go back to data center. Well, what is a data center today? 1.5% of the world energy, 189 terawatts per hour, and can be produced by clearly 20 nuclear plants. When you look at the forecast, we're talking about 4%, 504 terawatts, 55 nuclear plants at the end. What that means? That means that in order just to sustain and to be sure we can power data center in the world with nuclear energy, we need to build an additional 35 nuclear plants by 2030. I'm giving those numbers, and again, nothing against nuclear energy yet. But I just want you to understand, I will say, what we are talking about when we talk about this exponential growth of energy consumption in our planet, just for data centers. You guys have all a mobile phone. You all are using data. You all are using taking pictures. Those pictures are sent all over the place. Well, you're part of the data producer. Are you the guilty one? Oh, that's a big question. I don't see anybody guilty here using data. Data is a fantastic tool. Allow me to be here in front of you, okay? Allow you to communicate with people around the world, to say, hey, there is a crazy French guy who's talking about energy consumption in Hong Kong, and you send that to your friend in the US and say, that guy is doing this. Oh my goodness. The good news is there is no carbon footprint. What is the carbon footprint of that message? The carbon footprint is the data center, what is on the back. And these data centers consume energy, consume water, consume data, consume electronics, create e-waste, and so on and so forth. So Let's be pragmatic here. 2030, 4% of the world energy. Where are we today? Biodiversity-wise, 69% of the biodiversity is gone. Nothing dramatic, but just a species, just one above billions. We are clearly, the statistic, if they are right, which I hope they are not, they announced by 2030, 99% of biodiversity being gone, which is not going to be a good thing. So what do we need to do? Well, we need to do some things. And if we look at the numbers, if you look at the trend, 2021, 1.5% of the world energy, 2022, 2%, 2030, 4%, and there is even now a university, I will say, of Buffalo in the US saying by 2030, it will be 8%. What that means? That means that today, with the technology that Immersion 4 has invented, you can clearly look that let's take the pessimistic numbers, only 4% of the world energy. By 2030, we can save 17 nuclear plants to build them, knowing that you need 7 years to build a nuclear plant. You can power 14 million homes for free with the energy consumed by data. And just with an average of 70% energy savings, where we are more on the 80% than on the 70%. So what that means? That means that without building any plant, building any grid, any transportation line, you can power house with energy that we all need without any degradation of services on data. And then, what else? Water consumption. I was reading today, I will say, an article saying that for every prompt on ChatGPT, you have what it is, 500 millimeters water consumption. Well, let's go on the numbers that we know now without expecting anything. But if we are really looking today, according to the numbers of Department of Energy in the US, for per kilowatts, we're talking about 1.8 liter water consumption. As far as I know, electronics doesn't like water. So why are we consuming water? If you have an answer, I'm good for that. Cooling, very good. So that's the point. So when you look at water for cooling, and when you explain all of this, what that means. In that schema here, you can see what is the spending when we're talking about 4% of the world energy, where it is standing. It is standing on water, energy for cooling, energy for IT load, and the backup system. But what about the rest? What about reusing energy? What about the carbon we are having? What about the infrastructure in terms of real estate? A data center is 5 to 7 meters high, is 500 kilowatt data centers. We can go with 115 racks and at 5 kilowatt per racks. And that's giving, I will say, the same surface of what we do, I will say, on Immersion 4. You can go on 3.5 megawatts with a building which have nothing to do with. So there is a lot of inner cost. We are basically not only looking at the energy standpoint, but the entire things that we need, from the real estate, okay, to the energy production. So what is paying for the infrastructure? The city of Hong Kong, taxpayers. What is paying for the energy production? Same things. What data centers are bringing to the business we are talking about? Just having your data and processing your data. Do we need all of this when we can cut all of this? Imagine that tomorrow you're able to build a data center on 2.7 meters high, 1.2 tons floor loading building. That's what Immersion 4 is offering, with no water consumption. What is a data center? Here it is. 2.7 meters high, 1.2 tons on the floor. Any building can become a data center. what is the thing? Well, liquid cooling is the way to go. Again, remember the cup of champagne? That's the same principle for the liquid. Back to the fundamentals. If you look at, and I will just for your imagination, imagine this is an electronic component, what I have here in my hand. This electronic component, when it's power, is heating up, is attracting static electricity and dust. Because it's heating up and is in the air, there is humidity, corrosion, oxidation. You take the same component, you put it into the liquid. All the problems I just mentioned are gone. And when those components are on the PCB, in order to protect those components from the aggressiveness of the air, you have what we call conventional coating, which is chemical layers on the top of each other, up to 7. And the last one is a brominated, which is fire retardant. When we talk about recycling electronics, only 17% of the electronics in the world is recycled. Where the rest is going? Well, 2 containers out of 3 are leaving Europe to be recycled in Africa, where they're put on fire and we all breathe this. It's not very smart, but that's the reality. So remember, on a food immersive, those chemicals are not needed. What that means? That means that these electronics become recyclable. So we are clearly, I would say, the very true answer talking about the e-waste. Then after that, there is the server consumption, electricity consumption. There is the data center technology, because of course, we are moving air inside these data centers in order to be sure that the air is going to be circulating from that little component, ASIC, GPU, FPGA, no matter what you call it, being at the right temperatures, inside the server circulating, inside the rack circulating, going to the in-row inside the cluster circulating, and then going inside the room in order to get either evacuated or to be recycled for what is left. Well, why doing all of this? Why don't we have a 2.7 meters high room where you have an AC to dry the air, and you can have 40 degrees in that room? If you use a containment which is insulated, like the one we're having that you can see down below, basically you solve the problems. The heat or the cold in the room stay outside. I would say the heat generated by the servers stays inside, and there is a liquid-to-liquid exchange, okay, avoiding, I would say, any overheating or any mechanical vibration, because there is no more fans. So you're basically solving all the problems, the reason why we have designed, I would say, server till the end. Well, it's never too late to be good. By the way, it's easy to make critiques about servers, about electronics, when we have been the guys creating the problem. I'm 60. I was part of the problem. I never thought that when we were starting 45 years ago, having servers, first of all, cooling wasn't even a question, but the e-waste, the heating, the infrastructure needed, and the action of the air were the problems, for a simple reason. Because it makes sense when we have some things in the air, we are breathing in the air, we are in the air. So we do some things in the air and we re-put it in the air. When we do some things into the liquid, it makes no sense, because said, oh, we are going in another environment. But think a second and look at your car. Do you think your car today is cooled by air? It's cooled by liquid. What is the water consumption or the cooling or the coolant consumption of your car to cool your engine, no matter where you go? And by the way, it's available for airplanes, available for train, for anything. 0, almost. You just have some refill because of little evaporation. Well, that's the same for immersion 4. Apparently they want me to stay on that. That's my last slide. That's coming. All right. So path to sustainability. When we get a chance in 2019 to be awarded the Best Use of ICT and Global Excellence Award by the ITU, they had a program and they say, well, do you want to have immersion 4 to be part of the sustainability? I said, absolutely. And the year after, they were looking about to move the program to something else. I said, I want to keep the sustainability things because as Immersion 4, this is the most important thing, sustainable. So designing systems were built for decades, and those systems will be able to use the energy only for what matters, meaning powering the IT load. And what about the legacy? Let's on board embed all the legacy of electronics to cool legacy of electronics the way it is. The Dell, Cisco, HP, and so on and so forth of this world going straight into the liquid. And that's what we have done. So when you cut on energy consumption, obviously, if you remember the first graph when we were talking about fossil energy versus renewable energy, because you have 70 to 80% energy reduction on data centers, the path of renewable energy can become bigger, meaning more sustainable, more decarbonized energy that you're using. And that's what Immersion 4 is bringing to the table. Then when we talk about temperature on the rise, well, let's put all the data centers in Iceland or somewhere else. Well, for me, I would say, well, let's keep the data center home and doing the same things. Why don't you create a technology which is climate agnostic, which is our case? And then the other thing is, how can we increase the density on data centers? How can we be sure that a data center can be built in any building and without the nocivity? Because I'm pretty sure none of you want to have his house or his apartment close to a data center. You don't want to hear that. Well, with us, you can have a data center, I would say, in the room next door. You will not even know there is existing something. It will make less noise than an AC. And then after that, how can we scale them? Well, very simply, we make a water loop, sealed water loop, like you have your heating and cooling system within your building, and you connect the DTM system one after another as much as you need. And then we push that on the, let's say, on another level. Immersion 4 decide not to sell their product. We decide to rent it. Because not only the liquid is guaranteed 25 years, but our system are built for, I would say, for decades. So when you're done using them, we take them back. That means there is no more decommissioning on the data centers. And now we talk about full circle, full recyclability. Of course, all the new technology to optimize, talking about AI, talking about server virtualization, and so on and so forth, can be completely used, but completely agnostic. It's independent. Immersion 4 is an infrastructure company. So what are the benefits? There is multiple benefits. First of all, nature is talking about greenhouse, CO2, talking about no upfront sizing when you design a data center because you want to pay as you grow, going to financial savings in terms of real estate, up to what is the return on investment on the data center. Data center return on investment is between 5 to 15 years. For us, is 1 year. What is the TCO? Normal TCO, 30%. Our TCO is up to 90%. Of course, you will see all of this. And all right, what is the change? This is data center today. Traditional tier 3 design, multi-layer, what they call the lifespan architectures. We are completely independent. You can design the same architectures no matter what your data center destination is all about. At the end of the day, you have a water loop and you plug the system one after another as much as you need it. Now the other thing, let's talk the other big elephant in the room. When we talk about CO2, greenhouse, let's talk also about microparticles. How much microparticles are generated? Why do we need to generate microparticles as data centers? We have equipped our system with CO2, greenhouse, and microparticle sensor. And since we're in production, we haven't seen any emission on microparticles of any size. We made at the time of COVID, I make a crazy paper. The paper was the Trojan horse talking about COVID-19. COVID doesn't fly, it's a virus, it's dead, but it spread. It was spreading based on microparticle. You take the world microparticle map, you take the COVID spread, it's exactly the same. The two goes together. And in fact, the COVID was using microparticle, which is human activity, pollution, in order to spread. and we all have been impacted by this. So it's important to understand that and be able to reduce when we talk about air quality, because it's not only about CO2 and greenhouse, which, by the way, we are emitting CO2 each time we breathe. So what energy production versus pollution? That's a big deal. Well, when we deal with immersion 4, I don't understand those. 80% energy savings, no pollution emission, no water consumption. So for me, it makes no sense. So again, where is the elephant in the room? The energy that we can save, which is the best energy we are producing, because this is the best use of it. I'm not going to go to that graph. I put that graph over set for you guys with all the information. If you want to know from where the information I'm giving you are taking out, you have all the link in order to check that by yourself. Well, let's make it simple. I have to, okay, 1 second. We're keeping air and water for us because electronics don't need it. We're going to be using a liquid to liquid in order to retrieve energy. And now we can speak after that sustainable data, because we can turn AI, algorithm, machine learning, deep learning, data mining as much as you want. It will be working very well, because at the end of the day, electronic is into the liquid. Everything is fine. And we are continuing breathing and drinking water. Electronic don't need that. Thanks for your attention.
Thank you very much, Serge, for the insightful presentation. Indeed, very innovative solution there for us to actually know how we can cool data centers in a different way. I love this pamphlet he just gave me just now before the session. No air or water needed to cool data. So that's really a very innovative approach to cool data centers when comparing with the traditional ways that we know. And in the following session, we're going to learn more, because we'll have another speaker joining us on stage for the panel discussion. And before I invite her on stage, once again, a reminder, if you have questions for our panel, please feel free to go to our Slido platform and post your questions. And we'll try to have our panel speakers to answer them during the discussion session just right after. And now please join me to welcome on stage Ms. Jacqueline Chong, Digital Innovation Lead Hong Kong Amazon Web Services, to join us on stage for this panel session. Please welcome Jacqueline. All right, please take your seats. And thank you, Jacqueline and Serge, for joining us for this panel session. So why don't we start with Jacqueline? We're very happy to have you with us for this discussion session. We heard a lot about the solution that Immersion 4 has to provide. So why don't we learn from you as a service provider? Well, SaaS business model has been advocated by cloud service providers. And how do you think does that actually help to reduce carbon footprint?
Yeah, so thanks for having me, and really wonderful presentation. So from AWS point of view, we always advocate, moving. Once you move your workloads to the cloud, you already immediately reduce your carbon footprint. And the reason is because of how the SaaS model works. We only pay as what you need, so a lot of wastage is immediately sort of like reduced. So we actually had this research report by 451, and then they sort of had these findings that once you move your workload to the cloud, immediately, it varies across regions in the world, but on average it's like 70% to 90% of carbon footprint reduction. So that is, I think, it speaks a lot how cloud is actually helping to reduce, as part of your sustainability strategy.
Yeah. That's an alternative, right? And to help us actually reduce the emission or the production of carbon footprint. And we talk about so much on sustainability, and this is what we actually need to work together to achieve as a global citizen together. So AWS is one of the biggest cloud service providers. Could you like to share with us how does your company implement sustainability in your operation when there is increasing dependence on cloud?
Yeah, so I don't know any one of you are aware of that. Amazon is actually a very big organization. So AWS is like part of Amazon, and then we have a lot of business operations. So this is actually the same thing that we walk our walk. We don't just talk the talk. And this is also the same strategy that we advise our customers that when it comes to being sustainable in terms of your IT strategy, there are like 3 pillars that we follow. The first one is sustainability in the cloud, off the cloud, and then through the cloud. So when we talk about sustainability of the cloud, it's obviously what it's been described. How we operate our data center, how we make sure it's most efficient. And then in the cloud is actually something that we help our customer. When you design your infrastructure, your IT infrastructure, be it like how you design your app, how you develop your app, how you sort of like design the algorithm of your AI workloads, there are a lot of things that you can do to make it sustainable. And then obviously the third part is what we really feel very enthusiastic about is sustainability through the cloud, because what we see is like when you sort of like gear your business model towards a more sustainable path, it actually creates a lot of innovation opportunities, and you can sort of like ride on cloud to help you achieve that. So these are the 3 pillars that we ourselves and even we would advise our customers to follow.
Interesting. So not only yourself as a company, but you also help your customers to actually help them achieve sustainability in their business models. All right. So let us turn to Serge again. We have this interesting question for you. We talk about the use of data. So which industry actually produces the most carbon footprint when we talk about the use of data?
Oh.
Do you have any idea on that?
That's a tricky question. So first of all, what is the carbon footprint? For me, the carbon footprint, if you're looking at my finger when I'm doing this, this is a carbon footprint. So I will dissociate carbon footprint and carbon emission. If you're talking about carbon emission, clearly the manufacturing are the one, building, I would say, producing the most, I would say, gas, whatever they kind. We talk about NOx, CO2, greenhouse, whatever it is, and microparticles again in the air. When we speak about data or digitalization, well, is the way we design data center, because unfortunately we are producing those. So the rethinking of those needs effectively to be done. Again, we have the demographics, which is playing against us or playing for us. All depends if, again, we apply the eco-conservation principles. So this is a tricky answer to say that, because we cannot point finger to some of them, because at the end of the day, it's the industrial era. This is where we are living. Now, one thing is clear. We don't go through the sky. So we need to optimize the energy for what's matter. And again, coming back to the same principle, going to AWS, well, we're starting our things, I was said, in July, so we put everything is available. So no one is perfect, nor do we. And we do believe that we will have a nice walk with AWS, and in many ways, not only on providing you a solution, but also on building product together, doing the manufacturing side of it, because you have specific requirements that we can all address. That's why we have been focusing really on standard. And this is very important today, to use standard-based product in order to be used by everybody. And that's where the real focus needs to be.
So everyone is involved in this.
Must be.
Right. So, well, this other question will be directed to both of you. Do you think the sustainability measures taken by data centers and cloud service providers can catch up with the carbon footprint caused by the expansion of infrastructure? Why don't we start with Serge? Yeah, you go first.
I go first. Well, we made a calculation using our technology on what will be the cost of carbon footprint, or more the other way around. What will be the carbon footprint, the carbon credit we can get using immersion 4 technology? And on the 250 megawatts data centers, we're talking about 45 million carbon credit, okay, getting back to the data center owner. Simply for one thing, we do not emit CO2, greenhouse. And in fact, we even have the idea to create, a carbon fund where we will include microparticles into it, because microparticles are the demise for our own Earth. That's the reason why when we speak about allergies and so on and so forth, up to cancer, okay, we are all subject to that. So the sustainability is air quality. The second one is definitely water consumption. We don't consume water. No more than your car, no more than your house, okay, that you're heating up or cooling off. So that's the second aspect. The third will be, what about the building constructions? How can we reduce this impact in terms of carbon footprint and carbon emissions? And we can reduce by 8, I will say, the size needed for data centers and increase the power by times 10 on the same size data room that you can have anything. So that's the way we answer it.
Right, it's very different. It's actually getting more carbon credit by using your solution. What about you, Jacqueline? What do you think?
So yeah, it's I know it sounds very simple whether we can catch up with the pacing, especially we obviously operate a lot of data center around the world. So the way that we look at it is actually a very complex system. And it's also not a linear equation. So it's not like, okay, when we do one thing, then immediately the other side of the equation will decrease. So that is why we have like a more holistic approach when it comes to, catching up or meeting all the targets, because all the major organizations in the world now, they have their own set of targets and then the KPIs to measure their progress. So obviously we have our own set, but to make it like easy for everyone to understand, we actually have like 5 aspects that we follow. The first one is energy efficiency. Definitely, as what I've mentioned, be it like in the cloud, off the cloud, or through the cloud, we are trying to make it as efficient as possible. The second aspect is we are a big purchaser of renewable energy. So the fact is Amazon is actually the biggest purchaser of renewable energy in the world. I think by now we have sponsored around 470 renewable projects all around the world. So that is like another approach that we do. The third approach that we do is actually circular economy. I remember we were seeing the racks and then all the sort of like the IT weights that we created, the e-weights that we created. So as part of our practice, we would try to, sort of like make a more sustainable design of our rack, and also as much as we can, in the sense that we always say security comes first, but we will still try to recycle what we can from what we dump. And then the fourth one is actually our water stewardship. So actually a very key figures that we are sort of like chasing now is like by 2030, the AWS, like just AWS operation, we are targeting at being water net zero. So in a sense, it's like what we just touched upon. However we are going to operate our data center, the goal is actually to make it a net zero weights in terms of water.
Okay, building on that, I would like to ask you the next question to follow up. Do you have any thoughts on the key market trends shaping the future data centers? What's your observation, or how do you think that will look like?
I cannot speak for the whole industry, but AWS, we are obviously we have all those operational aspects that I talked about. Another big aspect, I think, well, we were talking about at the back, that the elephant in the room is definitely the computing power. So a lot of us are, increasingly relying on AI. And then there is no secret that actually consumes a lot of computing power, hence the energy consumption. So one of the trends that we see is like the chipset design. How, as a responsible sort of like cloud technologies provider, what we are trying to do is like aiming and then to pursue a more sort of like energy efficient chipset design. So we obviously have Graviton 3, which is like a lot of you, if you're on AWS, you're using the computing power powered by these chipsets. And then Graviton 3, it's actually using 30% less energy, consume 30% less. So this is one way that we achieve that. And on the other hand, because the AI, we see that is the trend that is upcoming, and then the demand would only be more and more. And that is why in terms of like the training, like AI, when we talk about AI, the most sort of like energy consuming part is the training part and also the inference part. So we have like Trainium and Inferentia, which are the chipsets that we designed just for, you know, making AI workload more sustainable.
Right. So to the, you know, small parts of what chipset to be used can actually help with that as well. And maybe one of the things that we can make the future data centers more sustainable. But Serge, what do you think? How about you?
Well, I like what I'm hearing. Because if I'm as an immersion for perspective, we can take everything which has been mentioned, from the chipset to the type of servers to the type of data centers to the use of renewable energy, and we are enhancing. In fact, we are making all those measures on steroids, because natively we solve the biggest problem at the beginning, which is we don't use air to cool data,
Right.
and that's from everything's start from that concept. If you remove the air aspect, there's so many things that you don't need. So obviously, every single measure you're going to take, from powering, from chipset, offset with least dissipation, and the use of natural resources, the building that you're going to design, are obviously getting a way smaller, a way more efficient, so a way more sustainable. So I love what I'm hearing. And by the way, it can be on cloud or it can be on premise, because data centers for us means a room is a data center.
And I know, Serge, a lot of our members in the audience are very interested in your solution. And we get a question from our Q&A platform. The question asks, how have the data center companies respond to your liquid solution? And is the liquid used for it is in a closed loop, or is the liquid polluted? Can you answer to that?
Absolutely. Well, they are more and more, let's say, receptive to what we have. Don't forget that human, we are rats of habit. So when we do things on a certain way, when we have procedures written on a certain way, talking about building design, talking about Time Institute and all of this, talking about the COP 1, COP 2, COP 3, people like to stay on those concepts, and they don't like to step outside of the box, even if the stepping outside of the box means for them a lot of savings. Except that now there is a big pressure due to the environment, pressure to the cost of energy, and also real estate. So if tomorrow you have an immersive cooling data center getting close to an air-cooled data center, you're talking about one data center with a return on investment on 1 year TCO 90% versus 9 years TCO 30%. So the economics are not the same anymore. We're going to become profitable very fast. Age is another issue. How can you become close to the edge? How could you build data center close to your home? Are you willing to receive an immersion for data centers? I'm pretty sure you're not willing to get an air-cooled data centers close by. So in terms of cooling, how we do to answer the second part, it's a liquid to liquid exchange. It's a sealed water loop. Our system contains the immersion for liquid, where you dunk any kind of electronics, any format, any size, any fiber, connectivity from 1 gig to 400 gig, okay, connecting and disconnecting into the liquid. And the calories go exchange between immersion for liquid to that water loop run into the building in order to cool or to heat up the building itself. And there is no water consumption, no more than your heating and cooling system you're using today within your building. Is this answering the question?
Yes, I guess so, because we have another follow-up question on your system. They wanted to know what are the difficulties of transforming a traditional data center cooling to an immersion for liquid cooling, and how can you overcome them? Any difficulties or challenges that you face during the transition?
There is none. Believe it or not, there is none.
Easy breezy.
Exactly. So imagine this is an air-cooled data center. You have an upfront sizing because you need raised floor, high ceiling, chemical fire suppression, air circulation, n-row cluster, okay, and to be sure you're going to maintain the hash rate. And I'm sorry for being too technical, but the hash rate temperature requested to be a tier 1 up to tier 4 data center. Well, This is an immersion for data center. 1.2 ton on the floor, 2.7 meters high, and then a water loop on the back. That's all what you need. And you can have air cool. You plug our system one after another. Plus on the time is based on demand. So you can plug our system one after another as much as you need it. Where at the end, when you design an air-cooled data center, everything is pre-designed. Because, for example, 500 kilowatts on 270 square meter is 115 racks at 5 kilowatts per rack. I apologize for being technical. I'm sorry. With us, okay, on the 270 square meters, you build 3.5 megawatts on the pay-as-you-grow, putting DTM one after another, no upfront sizing, and the temperature here can be as much as you want, 20, 30, 40 degrees. It's your call.
That's amazing. Well, feel free to stay behind and talk to Serge after the session. And it's very interesting to know how your solution is being very attractive to our audience. And let's take us back to Hong Kong. And I would like to ask Jacqueline the next question. As we see Hong Kong data center market is expected to actually witness strong growth over the next decade as demand for computing power and cloud services grows with the city's continued digitalization. We all know Hong Kong wants to become the international INT hub, and that's a well-known thing that we want to go together. And what are the key factors that contribute to building a world-class data hub? What are your views?
Yeah, so I think I'm not going to pretend to be the expert of data center design, but while we are on this matter, I would actually really want to draw back the attention to how we operate our data and then how we sort of design the things that you put on cloud. So I think that would probably be one of the aspects that we focus a lot on, which is about, it's one thing that we choose to go with an infrastructure that is, environmental friendly. But it's also the other things how you are going to design the applications and make it very efficient. So going back to what I mentioned earlier, using AWS as an example, the way that we approach this is we actually have what we call well-architected framework. So when we work with our customers, we actually have several governance pillars to help them. It's not just about make it more energy efficient. We actually have security pillar. We also have another pillar that help them to cost optimize. So when we talk to our customers, and then it's actually very easy for them to understand. Okay, if by the end of the day I want to achieve cost optimization, which is always the #1 goal of our customer, immediately you are actually sort of compliant with what we call the sustainability best practice, which is our well-architected framework of sustainability. So I think that is going back to your question, that is the approach that we are trying to sort of not really educate, but then accelerate our customers' sort of journey to be more sustainable on the cloud.
Yeah. So Serge, what about you? What do you think about the world-class data center hub? What can we do? What are the key factors that we will need?
Collecting data at the edge, processing them at the edge, using immersion 4 all over the place where you need to put server on it, or the competition or immersion 4, don't get me wrong, because the market is massive. So it's going to be 100 or 1,000 companies like immersion 4. And I hope it's going to be a lot of them in order to give to the big guys many options in order to take maybe something different. I just hope we're going to remain as immersion 4 on the top of the game, because that's the reason why we did it. But come on, let's be serious. I'm 60, okay? So in 20 years from now, I'm going to be 80. I'm going to be gone from here. So it's time to have a lot of people here in this room to take back, okay, and to enhance immersion 4 technology, liquid-to-liquid systems, in order to make it happen on a bigger scale. I'm very pleased that, we're going to be going to China next week, not next week, in a few days. We have a lot of things going on over there, and in every country. We're on Middle East, US, Africa. So that's very important to understand that with the concept that immersion 4 has been developed, there is no, you're late, you're not up to date. In fact, even the countries which are not developed on data, they are on time, because they're going to be using the most efficient technology for what matter at the lowest cost. So that's what is important. Now the thing is, there is innovation. Innovation means nothing if it is not used. And the acceptance of innovation, sometimes we need to step outside of the box. Sometimes we need to rethink what is the problem. And what I'm saying, through Immersion 4, we are not doing a technology, I would say for a technology, let's take market share. No, we are doing a technology we answer a real need, talking about pollution, talking about use of natural resources, talking about physics law, because at the end of the day, I'm sorry, my cup of champagne, I don't want to cool the room to cool the champagne, otherwise we'll be all frozen before starting to have the champagne being chilled. I want to cool the champagne and stay in bathing suit. So that's those principles that we need to go back to fundamentals. As humanity, I'm urging you, we need your help in order to get back into that, to make pressure, if you follow me to say, on the big guys, and to make pressure on us to get better, because that's the cost to pay at 8 billion people.
Yeah, and it's really good to know that we have service providers like you, like the innovative solutions that help us to achieve sustainability together. And it's important for us to have also large-scale companies like Amazon and AWS to actually spread the message, not only to the people that are working together, to your team members, but also to your customers, because they are the ones who will be using these technologies or solutions. So one last question, perhaps. I know we have our audience here, not all of them will own a data center or they will be using the data center, as a company, but we as individual users, what are the advice or tips that you can give them if we want to achieve sustainability eventually together? What are the things as individual consumers, what can we do? Is there anything specific that you give us as a tip or as an advice?
It is like $1 million question. Yeah, I think I really want to circle back to what we have all been talking about. It's definitely an ecosystem play. It's an ecosystem play. So a lot of time, and we do see the trend. We do hear even enterprise customers coming, and they really want to partner with companies that really have a strong angle and a strong view, and even already taking initiative to be more proactive in terms of being sustainable. I think that is one thing as a consumer and end customers, we all have these rights. You can choose to buy from companies that is promoting this message. I think that is key, because once you do that, there is the driving force for the company to come to us and then asking for more sustainable solution, and that is actually a driving force for us to innovate for sustainability as well. So that is one key message that I want to share.
Choose the right company, yeah, to purchase or to work with. Okay, how about you, Serge?
Well, I will answer a little bit differently, even if I completely agree with what you said. Ladies and gentlemen, you have a brain. You think on your own. You don't need ChatGPT in order to tell you and to give the right answer. Walk the walk. Otherwise, you will not understand what you're doing. When you speak about sustainability, we are human. We need water, we need air. We don't need pollution. We don't need water that we don't need. Don't forget that in 2025, 1.8 billion people will not have access to clean water. Again, I want to be wrong. If I'm wrong, my kids have a future. Maybe you too as well. The other thing is, use your phone. Use your data. Collect data. Check information. Look. Don't look at fact and other fact and everything. Look for information the way we want to be using it in order to understand situation. Don't be the receiver. Be proactive. And through this, be sure that the factory of the new age, the data center on the back, are sustainable on the way that no pollution, no use of natural resources, and less energy consumption. You need electricity to power your house. If I'm here, if I'm switching off electricity, what's left? Nothing. It's your call.
All right, that's a very good reminder, really. So, well, with that, we'll conclude our session here. Thank you once again, Jacqueline and Serge, for joining us for this panel.
At SmoothBiz, we're on a mission to make business easier for small and mid-sized enterprises. Introducing Smooth, your all-in-one digital workspace for company secretarial management. And now, meet Smooth ESG, your AI intelligence tool for ESG readiness. Navigate the complexities of environmental, social, and governance factors with ease. Join SmoothBiz for a seamless journey to growth. Visit our website to explore Smooth and Smooth ESG today.